All right, today we're diving into something that sounds like it's straight out of science fiction, but it's very real. It's called GridOS, and it's being described as an autonomous power nervous system. Yeah, you heard that right. A nervous system for our power grid.
And really, this whole thing kicks off with a question that I think we've all asked ourselves, probably while sitting in the dark. What if the power just never went out again? I mean, seriously, think about it. No more flickering lights in a storm, no more massive blackouts paralyzing a city, just constant, reliable power, always. So, to really get why that's such a game changer, you've got to look at how things work right now. Our current power grids, they're mostly centralized. Think of it like a massive tree with one single trunk. It's strong, for sure, but if something takes out that trunk, a big storm, a cyber attack, whatever, the whole thing comes crashing down. That single point of failure makes the whole system surprisingly fragile. Okay, so if the old way is a brittle tree trunk, what's the alternative? Well, what if instead of a rigid skeleton, our power grid acted more like a biological nervous system, something that's smart, spread out, and can react in an instant? That's the huge shift in thinking we're going to unpack here. And this quote from the people behind the system just nails it. They say, "We build the nervous system for the modern city." I mean, that's not just about engineering, right? It's not just about pipes and wires. It's about creating something that's alive, something that thinks. So how do you build a nervous system like that? Well, the basic building block, the individual nerve cell, if you will, is something called an autonomous microgrid. Just picture a small, self-sufficient power bubble. It could cover a hospital, maybe a whole neighborhood, or a super important data center. It can happily run all by itself, or it can connect to the bigger grid. Each one is a little node in this giant interconnected web. But wait, what's the magic that makes it autonomous? It's not just the hardware. This is where the software, the brain of the whole operation, comes into play. That's GridOS. It's making an insane number of smart decisions every single second, all with one goal: keep the lights on, come hell or high water. Okay, so how does this brain actually think? It's basically running a constant three-step loop. First, it predicts. It's using AI to look into the future, see a power spike coming, and get ready for it before it even hits. Then it coordinates. This is cool. Different parts of the grid can automatically trade power with each other, peer-to-peer, to make sure everything stays balanced. And last, it verifies. Every single one of those trades gets locked into a blockchain-secured ledger, so it's all completely transparent and tamper-proof. And you have to understand this speed we're talking about here. This isn't something that happens over a few minutes. We're talking about millisecond precision. This system is making decisions and coordinating everything faster than you can blink. Way, way faster than any human could ever hope to react. All right, so the system is a genius. We get that. But is it tough? Can it take a punch? Well, it turns out it's not just smart, it's built like a tank. The creators call it military-grade armor, and it's designed for one purpose: to work in a world that absolutely cannot afford to stop. And this toughness comes from three core layers of resilience. You've got physical hardening, you've got cyber immunity, and then you have this incredible fail-safe they call island mode. Let's dig into that a little. Physical hardening, we're talking things like EMP-shielded containers. So yeah, protected against electromagnetic pulses. And the cyber side is even wilder. They use air-gapped controls, which is a fancy way of saying the most critical parts aren't even connected to the internet, period. Plus, they're using quantum-resistant encryption. They're literally preparing for attacks from supercomputers that haven't even been built yet. That's some next-level thinking. But out of all of this, the ultimate survival instinct, the real ace up its sleeve, is island mode, because it answers the one question that really matters. What happens when the big main grid goes down completely, like a catastrophic failure? This is what happens. The main grid goes dark, total blackout. But the GridOS microgrid, it instantly disconnects itself. It literally becomes an island of power. And the craziest part, the lights inside that zone don't even flicker. For everyone inside that bubble, the blackout just didn't happen. It's like it never existed. So, when you put it all together, the smart brain, the tough-as-nails armor, that incredible island mode, what does it actually mean for us? What does it look like in the real world? Well, it leads to the creation of what you could call the always-on city. And to really see this in action, let's take a peek at what a live system dashboard for one of these microgrids looks like. This is the view from the control room, so to speak. What does a perfectly balanced, autonomous grid look like right now? Okay, first up, let's look at generation. The solar array is just cranking out a massive 1.2 gigawatts of power. To give you some perspective, that's enough juice to power around 1 million homes. All of it clean, all of it generated right there.
And it's not a one-trick pony. Check this out. A hydrogen turbine is also kicking in another 850 megawatts. Now, this isn't just about having big numbers. This mix of sources is the key to its stability. You know, if clouds roll in and solar dips, that turbine is already running, ready to pick up the slack instantly.
All right, now let's flip over to the demand side. The grid is currently running at about 78% of its total capacity. That extra 22% buffer, that's the good stuff. That's the headroom. It means the system isn't even breaking a sweat. It has plenty of power in reserve to handle any sudden surges, no problem.
And the final piece of the puzzle, storage. The battery system is sitting pretty at 92%, and it's still charging. This is that critical shock absorber, right? It's ready to jump in within milliseconds to smooth out any little bumps, whether it's a dip in supply or a spike in demand. So when you see all these pieces working together in perfect harmony, the AI predicting, the hardened gear protecting, the batteries balancing it all in real time, you get it. You realize what this is all about. This isn't just about keeping the lights on. It's about delivering something much bigger, true autonomy, and even more important, true resilience. And all of this leads us to one big final question to chew on. Our world is only getting more connected, more digital, more dependent on electricity that never fails. So is this smart, tough, decentralized network, is this the blueprint for how we'll power the cities of tomorrow?